Hello, welcome to this channel Chemistry Made Easy by Dr. Ashok Murik. Today we will begin with new topic, that is Ionic Bonding and Structure. So under this title we will see first point, energetics of ionic bond formation, and later on we will see this Born-Haber cycle in next lecture. So in this energetics of ionic bond formation, and before that we will see what is ionic bond. First of all we will see what is ionic bond. So here we know that during the formation of compounds or minerals in the earth's crust or anywhere in the universe, the various atoms of various different elements come together naturally and undergo formation of various compounds. Out of all these compounds, some of them are ionic in nature. It means when these compounds are dissolved in water, they split into their ions, that is cations and anions. So such compounds which when dissolved in water split into their corresponding cations and anions are also called ionic compounds. So such ionic compounds are formed when there is one atom from the element of more electropositive nature and another atom of more electronegative nature. We can consider here a simple example general, that is say A is the atom of electropositive nature. So this atom has a tendency to lose one electron and form A plus ion. A plus ion, that is, this is called a cation. So this is called a cation. So the atom of electropositive nature, that is element, has a tendency to form a cation by loss of one electron. So such atom A is one of the important requirement in the formation of ionic bond. Second atom, say it is B. This is more electropositive and this is more electronegative. So this atom has tendency to gain one electron and form a mononegative ion, that is called an ion. So these ions, this cation and this anion, when come together, that is A plus from its gaseous state and B minus from its gaseous state, gives us A plus and B minus in the solid state. So here this solid is called ionic solid, and the bond present between these ions A plus and B minus is called ionic bond, and this is of strongly electrostatic in nature, and that is why when such ionic solid is dissolved in a polar solvent like water, it shows the splitting of this compound AB into A plus and B minus in the dissolved state or in aqueous solution form. So such type of formation of cations and anions followed by the ionic solid takes place only when the cation is obtained from the atom of more electropositive nature and the anion of electronegative nature. Then such type of transaction takes place in order to attain stable inert gas configuration in both elements in such case. So this atom is initially neutral state, it is unstable. But when it is converted into A plus, it becomes stable, or that stability is attained by this in this form only by loss of electron. Here also the anion, that is atom of B, that is element which is electronegative in nature, more electronegative in nature, it also attains nearest inert gas configuration by gain of one electron, and that is why both these A and B attain stability, forming A plus and B minus. These are further combining together to give the solid called ionic solid. So this is the process in which the unstable atoms are converted into stable species. Now here we will see the ionic bond. So we have seen this, that is the ionic bond. So ionic bond is the bonding by means of electrostatic force of attraction between the atom of strongly electropositive element and the atom of strongly electronegative element, which results in the formation of ionic solid. So here we can consider this general form into examples. So we can take the example of, say, sodium. This sodium atom is existing in the solid state, but it is strongly electropositive. So it has a tendency to donate one electron with the formation of Na plus in gaseous state with the loss of one electron. So this is called cation, monopositive cation. Similarly, there is Cl minus, which is in the gaseous state. It takes up one electron and it is converted into Cl minus, that is an ion, chloride ion, that is an ion. So after formation of this Na plus and Cl minus in gaseous state, it gives this Na plus from gaseous state combines with Cl minus in gaseous state to give Na plus Cl minus in solid state. So this is called sodium chloride. This is called sodium chloride, that is ionic solid. So this can explain us how the ionic bond is formed. So we can use another solids such as calcium here. So we can have calcium. So calcium is also converted into calcium Ca2 plus with the loss of 2 electrons, and it gives Ca2 plus. Similarly, we can take here Cl2 plus 2 electrons, it gives twice Cl minus, and here we can have the Ca2 plus plus twice Cl minus to give Ca2 plus Cl2 minus Cl2, that is calcium chloride. So in this way we can explain number of such examples. Now the next example is, you can try this type of ionic bonding in various other examples. Then we will see the 3 important terms which are necessary to understand the process of ionic bond formation. So that is called energetics of bond formation. So out of this, the first term is ionization energy, that is represented as I. So this ionization energy is defined as the amount of energy absorbed by the substance in order to remove the outermost electrons from the atoms of this substance, and it is converted into the corresponding cation, maybe either monopositive cation, then it is called ionization energy. So here the electron lost by the atom when it is one, it is the resulting cation is called monopositive cation, and the ionization energy in such way or in such case is called first ionization energy. Similarly, that monopositive cation can also show the loss of one more electron, and during this it is converted into dipositive cation, and during this the ionization energy is called second ionization energy. Similarly, we can have third, fourth, fifth ionization energies as per the structure or electronic structure of that particular atom. So this ionization energy can be represented here as Na in solid state. So when this Na is in solid state, it is required to be converted into gaseous state for sublimation. When it comes in gaseous state, it shows loss of one electron and is converted into a gaseous state. So this is called a formation of Na+, that is monopositive cation. And during this process, the ionization energy I is negative sign or positive sign, because energy is required for removal of outermost electron from this species. So with the Na, here electrons in the sodium energy level are 11. It indicates number of protons as well as number of electrons. But after the loss of one electron, this Na+ has same atomic number, but the electrons are only 10 electrons are. So this is equivalent to the neon configuration, that is inert gas configuration. So this Na is thereby stabilized by attaining this neon configuration containing 10 electrons. Then so we can have this Na+, Na2+, Na3+, but which may require different amounts of energy for the removal of corresponding electrons. Then we will see the second term, that is electron affinity, that is E. So this electron affinity is defined as the amount of energy lost when the atom of neutral gaseous atom, that is when the neutral gaseous atom of electronegative elements gains one electron, there is some loss of energy, and that loss of energy is called electron affinity. Here also we find that the element can have first electron affinity, second electron affinity, and third electron affinity values. So we can take the example of this chlorine. So chlorine is in the gaseous state. So it can absorb one electron or take up one electron, and it gets converted into Cl- in the gaseous state. That is, it forms anion. So during this formation of anion, the energy E is lost. So it is given by or represented by -E. it is represented by minus. So this is called electron affinity. So this is one way of defining electron affinity. There is alternate way and the most commonly used way of defining electron affinity is this. So you can see this in the reverse form reaction. So you take up this chloride ion in gaseous state, and if we supply some energy to this chloride ion in order to remove this outermost electron, in order to form its Cl atom in the gaseous state with the loss of one electron. So the reaction is taken in reverse way. So electron affinity is also defined as the amount of energy required to remove the outermost electron from the negatively charged ion in gaseous state to form neutral gaseous atom, and this is called also E, but it has, we are not showing any sign, but it is also considered to be positive side, or it may be any sign. It may have either positive or negative side depending upon the electronic structure of the atom. So here the sign is not mentioned. It may be positive or negative. So this definition is mostly followed in standard calculations. Then third term is lattice energy. Lattice energy, that is U. So when we can take the previous example, that is the formation of Na plus in gaseous state plus Cl minus in gaseous state. So after this, when the cations and anions are combining, it gives Na plus and Cl minus ions in the solid state. So this is called lattice. So formation of this lattice takes place with the loss of some energy, and this is called U. So U represents the lattice energy, and since it shows the loss of energy, it is represented with negative sign. So that is lattice energy. So here Na plus in gaseous state combines with Cl minus in gaseous state and gives Na plus and Cl minus in solid state, called the crystal lattice or ionic lattice or solid. So with this, here we will stop, because the three important terms are studied here in order to study or help the discussion in various types of theories. So we will stop here. Thank you very much for watching. Please press the like button and bell icon button, and subscribe to this channel if not done, and keep watching and sharing this video. Thank you very much.